All right. Well, it's 7 o'clock. So let me make sure that I have the chat up so I can still view that. Okay. So today I'm doing solving radical equations with two radicals. So I have a video on the left side of the class under all the videos. There is one we're solving with one radical. When you're solving with two, it actually is easier than one most of the time, believe it or not.
Hmm.
Um, so it seems you would think that, oh no, I have more than one, it's going to be harder. Most of the time, it's actually easier, but there are some little quirks that you have to kind of think about. So just if you haven't watched the video on the first one, solving a radical equation with just one radical, just kind of a review. So when we're saying radicals, it has basically that square root symbol. And last week we learned how to simplify radicals. And this is really key because we were using the rule, and let me highlight it here. So we were doing this when we were simplifying, where you've got your exponent on the inside of the radical, and then you have the root on the outside and it cancels out and you just get the thing without the exponent. This is equivalent to if you have it in the other direction where you have a radical and then you take an exponent outside of the radical. So those are equivalent, and that's what we're going to be doing when we're solving is we have a radical, and then like if it's a square root, you're going to square to get rid of it. So it's the same rule essentially. It's just you could rearrange the order of those. And the reason why that works is because a radical can be written as an exponent. And so you're just rearranging the order of exponents. And we're allowed to do that because when you simplify, you multiply the exponents in order of multiplication. The commutative property means you can switch those. So that's all we're doing here. And so we're taking the same rule, we're just kind of doing it in a different order. And that will allow us to cancel out the radical and be left with just what's inside. And that's what we're going to be doing to solve radical equations. And so if it's got a radical with a variable in it, it's a radical equation. That's the simple rule for recognizing it. So when we're solving these, our goal is to get rid of the radical. So if you have a square root, you want to get rid of the square root, and we're going to be doing exponents on both sides or raising both sides to an exponent or a power. So if you have square root, you're going to be squaring both sides to get rid of the square root. If you have a cubed root, you cube both sides. So that's what we're going to do to get rid of that symbol. Now, because of the process of exponentiating, basically taking things to an exponent, sometimes this gives us extra solutions that work in the solution or the equation that we created without the radical, but don't work when you have the radical in the equation. So these tend to occur when you have even exponents that you're doing. So if you're squaring or you're doing to the fourth exponent or the sixth. So you always want to check your answers because this whole process sometimes comes up with extra answers. And then you do want to look out for if you have a radical that is an even radical, like a square root or fourth root, and it's equal to a negative, those have no solutions. That's generally not going to occur for us in this thing because we're going to have a radical equals a radical. So you won't have really like a negative on the other side, but it is something to look out for. So the steps for solving a radical equation with two radicals is very similar to what we do for one radical. There's only one change, and that's right here. So if you watched my other video that I have, solving with a radical, these are the same directions. There's just the highlight stuff is the only part that changes. Is that when you have one radical, you want to solve it so you have that radical by itself. If you have two radicals, you want one of the radicals by itself. So you're just trying to get one of them by itself, and then the other one might have some other junk on it with it on the other side of the equation. But you want to it doesn't matter which of the two you get by itself. You just usually pick the one that's easiest. and make sure there's no coefficient in front of it. So once you've got one of the radicals isolated, then you're going to raise each side of the equation to that exponent that will undo the radical. And then you solve whatever you have left and then check your work. And you always check with the original equation you started with. So the steps are basically the same. It's just you have to choose one of the radicals that you want to get by itself rather than you have no choice, you just get one of them. So we're going to go through lots of examples here. I have 5 examples, and they're going to start from sort of easy, and we're going to get harder as we do. So we've got the square root of h plus 4 equals the square root of 2h minus 5. So we have a square root equals a square root. So we already have the radicals isolated, where you have one side that has nothing but a square root thing on it. So these are already isolated, so we don't have to do any manipulating. We're going to solve this by squaring both sides. So, oops, I'm in the highlighter. I do not want the highlighter. So if you have a square root, you want to square both sides. So I'm going to rewrite our equation here just so I can show that step. And I'm going to do that in a different color. So I put parentheses around them, and then we're squaring. So that exponent of 2 will undo the square root. And what you're left with is everything that's under the square root. So you're left with h plus 4 on the left and 2h minus 5 on the right. Because on both sides, the square roots cancel. So you don't have that at all. They're completely gone. So now you've got a linear equation to solve. So we started with a radical equation. We square both sides, and then that gives us a linear equation, and then we solve for h. And it doesn't matter which side you solve for h on. I just usually go on the left side. So I'm going to subtract 2h from both sides. And I always subtract my variable first. So I have that where I want it, and then I deal with everything else. So we've got h minus 2h. So that's a 1 minus 2, which gives us a negative 1. So that's a negative h plus 4 equals negative 5. Then I'm going to subtract 4 from both sides. So hopefully at this point in the class, solving a linear equation like this is pretty simple, and you've got a handle on this. So negative 5 minus 4 is negative 9. And then we want a positive h. We don't want a negative h. So we're going to divide both sides by negative 1. And that gives us a positive h equals a positive 9. So the solving here is not so bad. We square both sides, the radical's gone, and then you just solve a linear equation. But we do have to check our work just in case, because sometimes we end up with something that doesn't actually work, and you need to check. So the easiest way to check is, I find, actually to do it in Desmos. So I actually use the graphing calculator to check. So I'm just going to open up the graphing calculator. So first thing I do is I just type in what did we get for our value of h. We got 9. So I'm going to just type h equals 9. Then what I do is I type the left side and then I type the right side, and then I see, do they get me the same answer? So if there's a little keyboard button in the bottom, you can hit the square root. So I can type h plus 4, and so it gives me some answer. And then I've got my square root again, and then I have 2h minus 5. And then I'm checking, okay, does the left side equal the right side? It does, so that means our answer works. I'm not using the graph at all. There's nothing graphed here. I'm only using this part because I can put in square roots like this and use variables. The other Desmos calculator, the scientific calculator, doesn't really allow you to do variables. So doing it this way makes it easier to check my work, because if we got 2 answers for H, I can then change it to the other answer and check. So this is how I check my work. It's the easiest way to check your work, because some of these, they take a while to solve, and then, to check it then takes even longer. So this is the square root. If we check something with cubed roots or something like that, you have to go into function here and then for miscellaneous, and then you've got other types of roots right there, but it defaults to the square root here. But you can see 9 does work. Are there any questions? So this example is also square roots, because I wanted to start with just square roots because those are the easiest. What's different about this example from the other one that we just did is that we actually have a number in front of the radical, in front of one of them. And so that usually causes people some, that's usually where the errors occur because of that. So our first step is to make sure that we've got a radical by itself. So on the left side, we've got a square root by itself with no number in front. So we're good. We can go straight to the squaring step. So like I did before, I'm going to rewrite this. And then I'm going to show the squaring. And this is where people tend to mess up. So the 2 times the square root of x minus 1 squared, that is the same as 2 times the square root of x minus 1 times 2 times the square root of x minus 1. And this is all multiplied together. So you're really multiplying the 2's and then multiplying the square roots together. Or basically you're squaring the 2 and you're squaring the square root. So that rule of exponent, where you have things multiplied and you have an exponent on the outside, that exponent is going to distribute. It just, most people mess it up because they're so used to distributing the exponent when you don't have things with square roots, but it also applies when you have square roots. So I see a lot of people, when they square both sides, they don't square the number, but the number has to be squared as well. So when you square both sides, on the left, the square root and the exponent 2 cancel. We get 5x minus 8. But on the right, we square the 2, which is 4. And then in parentheses, you get the result of squaring the square root. So that's another thing, is some people, like the 2 common errors here, forgetting to square the 2, or squaring the 2 but not putting parentheses, and so they end up with 4x minus 1 versus 4 times x minus 1. So it's really important to make sure that, watch out for both of those types of errors, so that you don't, if you don't make one, you might make the other one. So just make sure that neither of those occur. So now we've got 5x minus 8 equals 4 times x minus 1, and now we're solving a linear equation. So since we're in week 4, and you guys should have lots of practice solving this, I want you guys to solve this on your own, like on your paper or whatever. And while you're doing that, I'm also going to solve it on the screen, but I'm not going to speak it out loud because I want you to kind of practice. And then when you get your answer, type it into the chat, or if you want, you can unmute yourself and you can say it out loud. But I want you guys to try to solve this and get an answer for x, and then I will also go through the steps here silently. Okay. So far, it looks like everybody's getting the same answer, and that matches with what I got. So you have to distribute, then you isolate your x, then you move the constant, and you end up getting x equals 4. So that is good. That's what people have gotten. So now we want to check our work just to make sure that the number actually works. So I'm just going to clear these out on Desmos. And now our variable is x. So I'm going to just type in x equals 4. And if you use x, it will show up on the graph, but the graph is not, we don't care about what the graph looks like because we're looking to see whether our answer matches. So I'm going to type in the left side, which is the square root of 5x minus 8. Help if I actually typed that right. Oh, and it doesn't actually want to plug in x equals 4. That's okay. I'll explain what to do here. Then the right side is 2 times the square root of x minus 1. Okay, so unlike when I did h, because x is a variable we graph, this Desmos is trying to actually graph it, and so it's not giving us the answers on the right. But that's okay. So if you look at the actual graph, we have a spot where all 3 of these intersect. And so you see we've got 4, 3.464. So when the left side equals the right side, that's telling us the left side is the black graph, the right side is the red graph. When they're equal, that's where they intersect. And so you can see that point where they intersect has an x value of 4. And this y value is the output. So your square root of 5x minus 4, when you plug in x equals 4, would be 3.464. And you would get the same answer if you did the 2 times the square root of x minus 1. So Jamie has a fantastic question. Couldn't we just change x to a different variable? That is completely, that also works. So, if you do it in x, what we're looking at is the intersection of the 2 graphs to get our x value to check. But yeah, I could change this to another letter like a. And then that you can see the y values that I got, 3.464, and then you get the same thing. So if you don't want to use x and look at the intersection of the graphs, you can just change x to another letter. And as long as you type everything correctly, you'll check your work and you'll see that, yes, 4 is the answer to this equation. Now, again, we have another square root problem here. This is where it gets a little tricky. So this problem, when we squared the right, we had to square the 2 and the square root part. Here, we've got the square root of p plus 2 minus 4 on the right. So we're going to have to square that whole thing. And it is going to be a little bit more work than what we've done so far. But we have the left side with the square roots by itself. So we can go straight to the solving or the squaring process. So I'm going to just rewrite what I've got here. And it's really important when you check your work that minus 4 is outside of the square root. If you put it inside the square root in Desmos, it's going to be wrong. So we're squaring both sides. And here we're squaring the square root of p plus 2 minus 4. So this is actually, we have to FOIL here because we don't have something that's multiplied here. We've got addition going on. So what we've really got is a FOIL that we need to do. So I like to do that work on the side and then put the answer underneath it after I go through FOIL. So we're going to multiply the first things together. So the square root of p plus 2 times the square root of p plus 2. So that's going to be squared. Then the outside, that's going to be square root of p plus 2 times negative 4. So I'm going to put the negative 4 in front and then p plus 2. Then the inside, again, we have a -4 times the square root of p plus 2. And I don't have enough room here. And then the last -4 times -4 is a +16. So I'm just trying to squeeze that in there. So we square the p plus 2 of the square root of p plus 2, that cancels out. So we have p plus 2. Then the inside terms combine to -8 times the square root of p plus 2. And this is why you needed to learn how to add and subtract radicals. And then I have this plus 16. So now when I simplify, I can have p and then plus 2 plus 16. I'm going to just put plus 18. Then -8 times the square root of p plus 2. So this is the type of situation where these type of problems get really complicated because I still have a square root. So on the left, I have the square root of p minus 6 squared. So that cancels. I have p minus 6. And then when I square the right, I get p plus 18 minus 8 times the square root of p plus 2. So when we squared, we got rid of one of the square roots, but we ended up with another square root. So we have to do this again. We're going to have to square both sides again to get rid of that square root, but we want to get that square root by itself. So I'm going to try to get the -8 square root of p plus 2 by itself and move everything else to the left. And then we'll square again. So this is where it really becomes a longer process. So I'm going to subtract p from both sides, which luckily for us, p minus p, that cancels. So that's going to make things a little bit easier for us because sometimes when you square, you're going to end up with a quadratic here. But those cancel. So we're left with a -6 equals 18 minus 8 times the square root of p plus 2. So now I need to move the 18 to the left because I'm trying to get that square root by itself. So I'm going to subtract 18. And so that will give me a -24 equals a -8 times the square root of p plus 2. Now, we want to get the square root by itself, so I need to get rid of the -8. So that's multiplied, so we're going to divide both sides by -8. And so I'm going to just kind of move my stuff over here. So this -24 divided by -8 is +3. So I end up with 3 equals the square root of p plus 2. So now we've got that square root by itself. We need to square both sides to get rid of it. So that's why I do this in another color. So again, I'm going to square both sides. And so we get 9 on the left, and then we get p plus 2 on the right. And then now we can solve for p. So we're going to subtract 2 from both sides. And we get p, oops, my number is on the left. I should write a number on the left. 7 equals p. So this one, I mean, it's not that much more extra work because we still had to kind of multiply our square roots. It's only a few extra steps, but it's really the FOIL part where people tend to mess up. And that's why I recommend that you write it down twice and go through the whole FOIL process to make sure that you FOIL correctly. Remember that you need to do the first, outside, inside, last to multiply that, because what I often see is people squaring the p plus 2 and then squaring the 4. If you do that, you're not going to get the right answer because you're missing half the problem. You've only got 2 out of the 4 things that you're supposed to get there when you do the multiplication. You can square that way if there wasn't a subtraction in there, But when you have subtraction, you can't square like that. You have to do FOIL. So let's check our work. I can use P. So we just found P equals 7. And so the left side, I've got the square root of P minus 6. And then on the right side, square root of P plus 2. And then I need to make sure that I move my cursor over so that that minus 4 is outside. Because if you don't move your cursor over and you get it inside, you can see that they don't match. But that's because this minus 4 is under the square root, but it's supposed to be outside of the square root. So you have to make sure you're actually outside of the square root before you type it. And then you can see, do we get the same answer? So we found P equals 7. The left side, we got the square root of 4, or square root of 7 minus 6, which gives us 1. But on the right, we get a -1. So this is what I said, we tend to get extra solutions when you square. And that's what happened here. We actually got solutions that don't work. We got a number, 7, but it doesn't actually work because the left side does not equal the right side. So it's called an extraneous solution. So if I put these to X so you can just see what that means graphically, what this means is that there's no intersection. So if there's no solution, it means these graphs that we have never intersect. So you can see they're kind of getting further away. It's kind of hard to tell, but the closest they are to each other is right around here, but they're never actually going to intersect. So that means there's no solution here. So I'm going to just mark that here. So when you check, it doesn't work. So usually we can just use the empty set symbol, or you just do literally an empty set on the squiggle and then the squiggle. Okay. So question somehow lost on the second portion. What did I miss on achieving the -1? So the -1, if I go back here, I change these back to A. And then we had A was equal to 7. That was, or I can change them to P. That was what we used, P. So this -1, if you replace P with 7, you get 7 plus 2, which is 9. The square root of 9 is 3. And 3 minus 4 gives us a -1. But that doesn't match with what we get here, because this gives us a +1. 7 minus 6 is 1. The square root of 1 is 1. So that's how you get this -1 here. You're taking the number we solved for, you're plugging it in. You got to do the square root part. That's probably what happened. Yeah, and that's one reason why I use Desmos to check. So that way, instead of like worrying about messing up with your order of operations, Desmos will do it for you. And then you can just say, okay, it doesn't work, and just leave it at that. Okay. So those are like basically these 3 that we've done with square roots. These are the 3 basic types of problems you'll see like this. You'll see where you'll have a radical equals a radical. You'll see a radical equals a radical with a number in front, or you'll see like a radical equals a radical with a number added on or subtracted. These are the 3 basic types of problems. And sometimes, maybe they're going to all be on the same side and you have to kind of move them around, but they will kind of end up into these 3 different categories. And so now let's look at these types of problems with other things other than a square root. So here we've got a cubed root. And so if you've got a cubed root, then you are going to cube both sides because you want to undo the cubed root. So if you try to square both sides, it's not going to work and you'll get some, I mean, you can pretend it works, but you won't get the right answer. So I'm going to rewrite my cubed roots. And then to undo the cube root, it's going to be a 3 out there, which here, doesn't really matter. We're still left with what's going to be inside the cubed root. But if you have things where you have like a number added on, then it's going to be more complicated. Like instead of FOIL, you now have to write it 3 times, and it takes a lot more work. But luckily, you're not going to see this type with cubed roots, because it's hard enough with square roots and having a FOIL. If you had to do a cubed root, it'd be a lot more work. So you're not going to see this type with cubed roots. They're only going to be with square roots. But you will see ones like this with cubed roots. So when you have a cubed root and then you cube, you're left with what's underneath. So we get 3b plus 6 equals 7b minus 6. So now you know what I'm going to ask you to do. Practice your solving, solve this on your own, and then you can type your answer into the chat. I did the hard part for you, the cubing. And I will work silently. All you guys are beating me to the punch. That's a good sign. If you're faster than me at this, then that's a very good sign. I'm also taking my time there. So you should get b equals 3. And we got many people getting that before I did, which is fantastic. So now we want to check our answer to make sure that this actually works. So I'm going to clear out Desmos here.
Oh no, the Achilles heel of my calculator.
I can't do cube roots.
All right, E times.
Oh boy.
Oh, oops, I meant to exit.
So yeah, if you use Desmos, which is very user friendly, I click functions, I make sure I'm in MISC, and then I'm going to hit the button for the nth root, and then I have to type the 3 up there to indicate a cubed root, and then I can go underneath it.
That wouldn't be very masochistic of me though. Right, so we just put the.
So since you can see that when you try to we do get the same answer, and one of the nice ways about you get all these decimals, so it's always nice to at least you can say, okay, all the decimals match, so that's good. So b equals 3 is the correct answer here. It works.
Yes,
our decimals match.
See, look, I got it too.
I that seems like a lot harder to do. If anyone else on this call, if you click on Andrew's, I don't know if there's a way to make it big. Oh, spotlight for everyone. I don't know if that means you can see it, but he's got a really strange calculator that he's typing in.
The desktop calculator by the GNU project for your command line. It's yeah, it's fast.
Probably the hardest one to do. Okay, now I've apparently put myself up on top to make sure all you guys can see me. Okay, so I've got 2 more. So this is another cubed root. And this, see that they're on the same side. So we've got the cubed root of k minus 8 minus the cubed root of 4k plus 1. So you do not want to cube it both right here. You need to get one of these by itself. So we're actually going to add one of them to the other side. And if there's one that's subtracted, that's the one that I add, so I don't get any negatives. So we're going to be adding, the cubed root of 4k plus 1 to both sides. So that way you do have one of the radicals by itself. And then all we have to do is cube both sides. And if it was something where you had like a plus, you would be subtracting for both sides. And then you had that minus in front of the cubed root, and you would have to kind of consider, okay, I'm cubing a minus here, but we don't have to worry about that here. And most of the time they give you these with a minus so that you don't have that negative to worry about. So I'm going to cube both sides. So that gives us k minus 8 equals 4k plus 1. And now I'm sure you guys are all going to beat me to this again, solving for k.
Yep.
Which is good, but I got to make sure I'm showing all my work for people who are only using the PowerPoint later. And don't rush too much, because sometimes then you do your math wrong in your head. All right. I kind of sped it up this time around, tried to rush. So we get a -3.
Oh no. Oh no, I hung my calculator.
That's why you should be using Desmos.
No,
so
it's the negative number in the root. It gets angry.
Yep. Okay. So we've got a -3 here. You want to be careful with your signs. Positive I by negative is a negative. So I will go to Desmos. So we got k equals -3. And we can put in the original problem here and just make sure it comes out to 0. So instead of doing like where I put them on both sides, I'm going to put in the original that we had. So we had the cubed root of k minus 8 minus.
Oh yeah.
And then the cubed root of 4k plus 1. And then you can see it equals 0, which is what we want, because 0 is on the right side. And this calculator doesn't get stuck, unlike your calculator, Andrew.
No, I have a trick. If I pipe stuff in the command line, it works sometimes.
So you can see that, yes, our answer works here. And for things with cubed roots, that's basically always going to happen. We don't get those extraneous solutions like we do if you have square roots or fourth root or things like that. Are there any questions?
Come on, calculator, you're embarrassing me in front of my friends. That's
all right. Well, you better not use that calculator on the quizzes, because clearly it's not going to work out for you.
I used it on the last of the assignments. I haven't done the midterm yet.
Well, hope it doesn't get stuck on there. Okay.
I have a TI somewhere.
Yeah, TIs are always good. Last one here, we've got a fourth root. So because it's got that 4, we have to keep in mind we might get extra solutions here. So we will find out when we check our work. But we've already got the radical equals to a radical, so we can just go straight, and we're going to take everything to the 4th power. So if you see the 4th root, then it's going to be a 4th power. So that exponent is going to be a 4. I'm going to rewrite this so I can show that. And you may be tempted to just do the 4th root stuff in your head, or the 4th power in your head, and go straight to writing 5a plus 3 equals a minus 13. And that's totally fine, because it's quicker to write that. But just be careful if you're trying to use your notes later on. You may be like, well, why was I allowed to do that? So when you're taking notes, it's good to write more steps than you think you need, just in case you forget steps later on. Because you might be like, oh, I don't even need to write it now, but you might in the future. So when I do the 4th root, all that stuff cancels. So we have 5a plus 3 equals a minus 13. And now we solve for a. And I'm sure you guys will beat me again. I subtract a from both sides. Yeah, you guys totally beat me. I'm too busy talking here, and you guys have already solved this.
Typeset it.
I have 4a plus 3 equals negative 13. I'm going to subtract 3 from both sides. We got 4a equals negative 16. And then I divide both sides by 4. And we get a equals negative 4. So now the question is, does this answer work, or is this going to be an extra? Is this going to be an extraneous solution? So I've got a equals negative 4. And then I'm going to do the fourth root now.
Oh, I know what I did wrong. I didn't put a multiplication symbol last time in front of my parentheses.
Oh.
My calculator doesn't imply the multiplication. It's kind of dumb.
That is, yeah, that is, Excel doesn't do that either. I have that problem with Excel, that it doesn't imply the multiplication here. Okay, so I've typed this in, and notice we've got some very interesting things going on here. So we solved and we got a equals negative 4. You plug it in, technically the left side and the right side match, but undefined means there's no solution, because we're getting undefined because we're taking the fourth root of a negative, which is not possible. So even though the left side and the right side do technically match, the matching parts are telling us this is not possible, because we're taking the fourth root of a negative, and you cannot have even radicals of negative numbers. And so this is not a solution, and this means there's no solution. So this is another extraneous solution that popped up. And so we have no solutions to this problem, because once again, if you try to graph these, so if I change that to X, there's going to be no intersection. So you can see they appear to stay pretty much the same distance apart the more I scroll here, and they're never going to intersect. So there is no solution, even though technically the left and the right both got undefined, but that's impossible undefined. So once again, we got an extraneous solution. And so I like to use the empty set symbol, but
there it is.
Otherwise it's just the empty set. So that's why you have to check your work, because, I mean, if you can be kind of lazy and not check the ones with the odd radicals, but if you've got an even radical, you need to check your work, because you might get numbers that don't work. Are there any questions?
I have a question when you're using the graphing.
Yes.
Where did you find the symbol so you can do the 4 in the right place? Because I can't find it when I was on there.
Okay, so very bottom, it says show keypad.
Mm-hmm.
And then I have to click functions. And then it will default to trig.
Okay.
Yeah, you need to click this MISC thing, and then that will give you all the extra stuff.
All right. Thank you.
You're welcome. Okay. So seems like no other questions. So that was my last example. So hopefully you guys are in good shape for doing these radical equations on your homework. And then that gives you a little 12 extra minutes for you to spend on whatever your discussions or whatever else you guys are doing today with your homework. Now, tomorrow, technically, I have a day off, because that's where we're observing our New Year's Day. They didn't give us New Year's Eve. They did Monday instead. But I will be checking my emails and being sort of on and off my computer tomorrow. So if you guys do run into issues or have questions, I'll be at my computer. It just won't be all day. So just want to give you guys a heads up there. So, and then this is our last holiday that we have. And so everything should be back to normal. No more holidays to mess up timing on things. So, all right. Well, you guys are welcome to go. And thank you. And I will see you guys next week. Same time, Sunday, 7 p.m. for week 5. Woohoo!